Welcome to Stay Free's Academic Tuition Center. With me here is a physics question on a velocity time graph or speed time graph under motion. Okay, so a question reads, a car slows down from a velocity of 40 meters per second to 20 meters per second in 5 seconds. It then moves with this velocity for 3 seconds and then comes to rest in 2 seconds. Okay, so question A is saying plot a graph of velocity against time for the motion of the car on the grid provided. So, okay, so I'll use this part, the space provided. So what I'll do here, I need to understand the question clearly for me to draw the graph. Okay, so from here now, I'll go back to the question. A car slows down from a velocity of 40 meters, so which means it's like the maximum velocity is 40 meters. So I'll put 40 meters, try to put 40 meters here. Okay, I'll put 40 meters here. So 40 meters here. So a car slows down from velocity of 40 meters to 20 meters, which means from 40, I'll say this is 20 meters here. So I'll put 20 here, 20 meters per second, which is speed. So from 40 here, it moved to 20 meters here a second. It then moves with this velocity for 3 seconds and then comes to rest in 2 seconds. Okay, so I'll repeat the question again. A car slows down from a velocity of 40 meters per second to 20 meters per second in 5 seconds, which means the time here is I put 5 seconds here, 5 seconds from 0 here. So which means it's from here to here, which is this time. So I'll draw a line like this. So it's like this, like this, like this. Okay, good. So in 20 seconds, to 20 meters per second in 5 seconds. So it's like this. Okay. So it moved from 40 meters per second to 20 meters per second in 5 seconds, like this. Okay. Then it then moves with this velocity, so which means with the same velocity here, which is 20 meters per second for 3 seconds. So for 3 seconds, which means 5 from 5, then it moved for 3 seconds, which means the number that I'll put here, I'll put what? I'll put 8 because I'll say 5 plus 3, which is 8. So which means it to be from here to here, which is 8 here, like this. Okay, 8 like this. Okay, for 3 seconds and then comes to rest in 2 seconds. So further 2 seconds. So again from 8 to 2 seconds, which means to be 10 here, because 8 plus 2, which is 10. So it will come to rest like this. So this will be my speed time graph. Okay, then I'll go to the next question, which is question B. Question B1. So calculate the retardation in the first 5 seconds. So for me to find retardation for the first 5 seconds, so 0 to 5 seconds, so this line from here to here indicates retardation. So I'll use the formula for acceleration, which is same as the negative acceleration, which is retardation. So I'll say acceleration is equal to v minus u over time. So note that v is the final velocity, u is the initial velocity, and t time taken. So acceleration is equal to, so my final velocity, as you can see, the starting point here, it was 40, which means our 40 was initial. Then it moved from 40 to 20. So our final velocity was 20. So I'm going to put 20 here, and then minus initial starting point to be my 40 there. Then over the time taken is from here to here is 5 seconds. 5 seconds. So I'll say my acceleration is equal to, so I will now subtract 20 minus 40, which is negative negative 20, then over 5 here. Then acceleration is equal to, so negative and positive to be negative here. So 5 into 20 to be 4. So the answer will be negative 4 meters per second squared. This will be the final answer. Then I'll go to question is B2. Total distance covered by the car. So they want me to find the total distance. So we need to know that the distance is the area around a given shape. So when finding the distance, the total distance, I need to find the area of this shape. So what I'll do here, I'll try to identify the shapes given. So as you can see from here to here up to here, this looks like a trapezium. Then the remaining part, which is the on top here, is the triangle, which is the right angle triangle, like this. So I find the area of the triangle plus the area of this trapezium, which is down here. Then it will give me the total distance. So I'll say distance is equal to 1/2 BH, which is the area of the trapezium. Then plus, the right angle triangle plus the trapezium is 1/2 A plus B, then height, like this. So my distance is equal to 1/2 times my base. The base of the triangle from here to here is 5. So I'll put a 5 here. Then times the height of the triangle from here to here. So I'll subtract 40 minus 20, which is 20. Like this. Then plus for the trapezium again. Trapezium, I'll say A is a number from here to here. So from 0 to 8, so which is 80. Then plus B is from here to here, which is 10. Put a 10 here. Then height from here to here, which is 20. Okay, then I'll simplify now the expression here. So distance is equal to, so I'll multiply here 1/2 times 5 times 20. So when I use the calculator, the answer that I'll get is 50. So 50 here, then plus, then here I'll say 8 plus 10 is 18. Then 2 here to 1, 2 here to be 10. So 10 times 18, which is 180 here. Okay. Then now from here, what I'll do, I'll say distance is equal to, I'll add 50 plus 180. I'll get 230. So 230 meters. This will be my distance. Then the last question is saying the average speed of the car. So we need to know that speed is equal to the total distance over the time taken. So that speed is equal to, so the distance calculated here is, as you can see, is 230. So I'll put 230 here. So 230 then over 230 over the time taken from here to here. The time is 10 meters. So I have 10 here. So my final speed is equal to, cancel this, so it will be 23 meters per second. This would be the final answer for the last part. Thank you very much.